Welcome back. In the previous lecture, the most important thing that we reviewed, besides the syllabus and the rules, the grading, the definition of analysis and design. What is the meaning of what the things that we're going to be doing here? Analysis. Understand the problem. What are the components, the elements, the parts of the problem, and the relationships. Hopefully this rings the bell to requirements. You have a problem, you analyze the problem, split the problem in the different parts, and those parts are your requirements. Very important idea. I need to be sure that you know, that you understand requirement and what the user wants, the necessities, the needs, the wishes. What I as a customer share with you is what I want the software to do, but those are not the requirements. You do, as an engineer, you not put that in a list and start working. You do an analysis process. The analysis process is understand the problem and really extract for the problem the parts, the requirements that you're going to complete. We're going to talk about it. But what? Analysis. The second one, design. Design, as we review, to create a model, a blueprint. Yeah, your class diagrams. That is the main example. To create a representation, a model, a blueprint that show how the final solution is going to look like without doing that final solution, because doing the final solution is expensive. You do the blueprint and then you build the house. In software, if you're doing something easy, you can go directly to coding. Usually it's not the case. You do diagrams. With your diagrams, you do validations, and then you go to building. Then you hire some programmers to do the thing. This is design, is going to be connected with models. Those are the two main topics that we're going to be covering. We need to start with these ones, right? But in both of them, requirements, analysis, or design, the blueprint, we're going to be dealing with one keyword. The reason because we're going to do analysis or design, the reason because we cannot just go and start coding is, in one word, because complexity. Complexity. Two ideas that I need you to be aware about complexity. Complexity in terms of software. What makes a piece of software complex? What makes a class or a method, a system, my next homework, complex or not? Number one, I am sure that you are thinking about this, the size, the number of components, yeah, the number of classes, the number of methods, and in the atomic example, the lines of code. More source code, more lines, the size is bigger, and just by definition, our brain become crazy, like this is too big. There are a lot of requirements, there are a lot of classes, there are a lot of methods, and just because there are a lot, it's complex. You ask for more time or maybe a higher payment because it's complex, it's a lot, it's big. There is a second thing that makes something complex. And I want to explain that with an example. You take a class of data structures. Do you remember trees? Hopefully, yes. Moreover, do you remember how to do the traversal of a tree? I am talking about the method that you need to do the traversal of a tree. In particular, do you remember how many lines that method has? How many lines of code do we need for a method to do the traversal of a tree? Yes, it's recursive. Very few. How many? Yeah, 3. I am talking about the number of lines inside of the method. The header of the method and the closing curly bracket is not relevant. How many lines inside? If you remember the traversal of a tree, the method have 3 lines. And one of those lines is just printing. 3 lines. Okay. I am sure that you review linked list or arrays. Do you remember here how many lines do you need for something like bubble sort or quick sort or some of them? Bubble sort, how many lines? Or a bubble sort or a quick sort? Yeah, more than 3, right? That is my point. It's more than 3. 10. Maybe, depending on your programming thing, but you have a loop, an if, plus some swapping things, 3, etc. Tell me, which one is more complex to understand? The traversal of a tree or bubble sort? I hope that you agree with me here. I mean, think about it. Bubble sort is something that you review in a 100 level class. It's something that you review at the same time that you were learning to program in Java. Some of you. Trees, traversals, that was at least a 200 level class. The complexity of this one is higher, even though it's 3 lines. The complexity of this is lower. It doesn't matter that there are 10 or 15 lines. Do you get the idea? Size is important. But when we're talking about complexity, it's not the only factor to consider. 3 lines, the abstraction, sometimes is more important than the size. And I want to connect this with one question that I asked in the previous lecture. In the previous lecture, we was talking about the number of lines of code that a programmer can create in 1 hour. And we have a discussion, I read the chat, about whether or not 10 lines was something that makes sense. It's an average, but also this programmer is only doing 3. And let's assume that in 1 hour figure out the traversal. And this one used 1 hour to figure out the sorting. This guy deserves more. The knowledge that this guy has, even though he's used 3 lines, is maybe above the other. Just remember that when you are reviewing software. You remember these 2 ideas. The complexity because the size, but more important, the abstraction level of each of those lines. What is behind of those lines? Explaining to you the traversal of the tree, explaining to you the 3 lines, is not about explaining you the 3 lines. It's about giving you the full context of the background of those 3 lines. And it's explaining recursion. Anyway, complexity, size, and abstraction. Moving forward, that is going to be in everything that we're going to review later. Now, a system that is complex, doesn't matter if because the size or is because the abstraction. Higher the complexity, doesn't matter why. The possibilities of the system to fail are higher. That is the real problem. That is my worry about something being complex. A lot of lines or a few lines, difficult to understand. Higher the complexity, easy the program is going to fail. And 2 things. Number 1, the problem with the system to fail is those 3 things. And the 3 of them at the end is money. If the system is delivered late, have a cost, maybe the cost increase in order to complete, or fail, we need to fix it. And the end is money. Now, if a piece of software fails, there are two reasons. In the same way that I am oversimplifying things and telling you that the problem is money, even though you can read the book, very nice descriptions. I am telling you, there are two reasons because a software project is going to fail. Can you imagine? Two reasons, two things that can go wrong. Number one is about the skills that you have, the technical skills that the people that you hire, the technical skills that the team that is developing the software has. Obviously, you want people with good technical skills because those technical skills are going to be there, applied to solve the problem. Technical skills are important. I am sure that is the first thing that comes to your mind. It's like, well, if something fails, it's because someone made a mistake. And if someone make a mistake, that someone do not have enough skills to be working in this particular problem. Technical skills, they are important. Yes, they are important. Is one of the things that I am mentioning. What do you think about the second one? Another thing that is equally important. Okay, you mentioned this. Communication. Soft skills, team working, the ability to communicate with others. You can have people with the highest level of technical skills. If those people do not have soft skills, if those people are not able to communicate and work together, your system is going to fail. When we talk about analysis and design, when we talk about understanding the requirements, when we talk about doing the blueprints, we need to consider these two things. The reason because we're going to do all the things that we're going to be doing here, all these diagrams for the requirements, all these diagrams for the classes and whatever. The reason because we do diagrams instead of start developing the product from the beginning is because we need to verify these technical skills, the knowledge of the technology involved, whatever, but also because we need to do something to facilitate the communication and team working between the people. Communication is important. And when I talk about team working, if you're working in a team, the main question that you have is, what is going to be my part and what is going to be done by others? Split responsibilities. You can be very good friends of your team, but when things go wrong, usually the friendship is like, well, that was not my part. I am okay. I want my A and the others fail, not me. What we do before that happens in order to avoid or facilitate the handling of those situations, that is the things that we need to review with analysis, design, and all these models and things. Okay, good. Now, again, I need to make the point clear. All those things that I mentioned, the money, the technical skills, the communication, soft skills, the analysis, the design, the blueprints, all of them apply here in the house. When I have a customer that is going to be telling me what to do, when I have an engineer that is going to have the blueprint, and then workers that are going to do the developing. If you're thinking about doing the house for your dog and you tell me, I like to just go open my IDE and start programming. Yeah, that is possible. You're working here, not here. It is fine. There are software that can be done in this way. Not all of them. You can figure out your particular cases. What you want to do, what you're going to do, in which company, alone, not, you need or not design an analysis. I am going to assume in all the class that we are here, that you are going to move here, not here. So everything applies to these big projects, professional projects. Anyway, as a summary in one slide, when I put this draw, the house for the dog, what I am talking about, what you are going to read in the textbook is, you know what? Applications that are going to go to the garbage. This app that you develop, and if work good, if not good. I am talking about, if you remember 360, about prototypes. If you're developing prototypes, go to your computer and start programming. Period. It's a prototype. You're testing something or learning something. Usually it's going to be one person. Why did you do a diagram if you're going to be the one doing the diagram and also implementing the diagram? Limited life and goals. That is the house of the dog. Obviously, hopefully you memorize these three words. We're going to be talking about them a lot. Extensibility, modificability, and reuse. With analysis and design, with these diagrams, those three are our goal. Those three are the main measures of quality in software. When we talk about quality in a piece of software, usually that involves, is not limited, but involve these three guys. Obviously, for the house of the dog, for a prototype of something, for one person developing software alone with a short life period of time, that software, who cares about extending, modifying, or even reuse? In the scenarios that we're going to review, this is the goal. Every single time that you do an assignment, every single time that we are going to be doing something, our goal, the things that we are doing is to achieve those. One solution, another solution. The good one is going to be the one that achieves those qualities. Good. In order to achieve those qualities, always, two problems. Number one, we need to take decisions. We need to make trade-offs. One solution, another solution. We need to decide, we follow this one or we follow this one. Always. If you have two paths, this is better for something, but when you follow this one, something else you are missing. This one is good, but the other is also good for a different thing, for a different scenario. One big example that we're going to review later, something that you review in 360, software design patterns. Software design patterns. We use the patterns or not? If you use the patterns, the good thing is a solution. It's a solution that has been tested. Follow that path and you're going to have a solution that for sure is going to work. What are we missing? Creativity and innovation. You're following something that is already been done. You're following a recipe with a goal. I want to be innovative. I want to explore my creativity. I want to do something different. Maybe you're going to find something better than the pattern. Maybe not. The risk, trade-offs. What do you want to do? Decision points. We're going to talk about it. The most important risk for the quality, human communication. We're going to talk about team working in the design. For the requirements, for the beginning of this, for the analysis, the main risk in terms of soft skills is communication. Communication, that you understand the same thing that I am trying to tell you, and the opposite. That is the big problem with requirements. One thing that we need to review in the following slides. But before that, you know what is the other problem? if you are doing the management of the project, if you are the leaders, if I have you as my team of developers, you know, one of my responsibilities is this. Even as an instructor, if you are the leader, one of your responsibilities is to make the people think that whatever you are doing is easy, that you can do it. It's going to be done. It's a little bit harder, but you're going to do well. You need to convince your people, your team of developers, that whatever they are developing is simple. How do you do that? How do you show someone that method or that class that they are going to create is simple? With a good design, with the blueprint. Check the blueprint. It uses 4 walls, a window, and a door. You can do it. Show simplicity. The people is going to work, is going to complete that part. Management, whatever. Obviously, all this is hypothetical because you can be thinking, well, I do not need to do that. 2 scenarios. Scenario number 1, you are going to work in the same way that the people is working to develop the buildings outside of the campus. You are going to work with people that are the workers that work with a leader, an engineer, and this engineer is the one to tell them what to do. And those people receive a good payment, something. Scenario 1. Scenario 2. And probably you remember 360. The scenario 2 in software is you can work as the people that develop the Egyptian pyramids. You can have a lot of people paying something like that, developers, and you can have them working again and again and again and again and again. And in some point, you're going to have a pyramid, something that is good. The total cost under the same circumstances could be higher here. But if you move down this, the cost is irrelevant. Scenario number 1, engineering. Scenario number 2, what is called the Egyptian pyramids method. Use brute force. Start programming. In some point, you're going to get something that works. Doesn't matter the complexity. Hopefully you agree with me that we want to follow this approach, not the other. Anyway, we want to follow that approach. Okay. We care about the quality. We care about the complexity, and we want to handle the complexity to have a team working on this. What we do? What we do? Step number 1. I have a problem. And the first thing that I need to do is to do the analysis. And from my problem, split the problem in sub-problems. I am not talking yet about requirements. I am talking about trying to split the problem in parts, just to understand the main problem. Question for you guys: how many parts? How many? And there is this magic number that we're going to be using a lot. According with this study, the number of ideas that you can handle in your brain, you, a human being, any human being, 7 plus minus 3, depending on a particular context, things in your brain at the same time. Things that you can remember to work and to take decisions. 7 things. Okay, I need to think in something, and if I have 7 or less, that something can be in my mind, and I do not need to put this something on paper. I do not need to create a document. I can have it here. I can remember. If we move beyond these 7, if the problem that you're solving involve more than 7, 10 requirements, things to do, you're going to forget them. You need to put them on paper. That is the reason because we have paper, right? That is the reason because we put things in a document, because we do not want to forget. We need to remember later. More than 7 requirements. Even the house for the dog involve more than 7 requirements. Almost any project that you're going to do that is not a prototype for something is going to involve you to documenting the requirements, even if you're going to be the developers, because you do not want to forget. Okay, documenting requirements. Do you remember what we do in order to document requirements? What we do to put requirements in a document? What options do we have? Well, Javadoc, and that is do documenting the source code, yes, but the requirements. I need a piece of software. I am going to ask you to do a piece of software. You want to be sure to remember all the requirements that I am going to mention. You put the requirements in a document, and that document have particular names. Yes. Do you remember that in order to document requirements, the first thing that you do, you are talking with your customer, and in that conversation, there are a lot of ideas, and you engineers take note of the requirements. We agree that the requirements are not the same as the necessities, and you document those requirements using user stories or use cases. Do you remember that, right? Now, user stories, use cases. The only thing that I want to be sure that you know is the diagrams that you create, those diagrams that looks like these things, 360. What you put here, the text inside of these ovals, those are your requirements. Remember, the diagram is a picture. It's a picture of different requirements, how they are connected. Moreover, which is the user, the actor that is involved in that requirement. That is what you have in your use cases diagrams. For the user stories, you do not need a diagram. For your user stories, the only thing that you care about is this, the text, the definition of the requirement. Yeah, in the user stories, you're going to follow a particular template as the actor, I want the requirement. We're going to talk more about the templates and even the diagrams. The only thing that I care right now is that we can explain this text here and the what part in the user stories, that we understand what is really a requirement in this context of being able to explain a problem. Now, requirements, use cases or user stories, they have the following qualities. If I ask you to give me a requirement for a project, if I give you an explanation of a piece of software that I need, and then you start working in defining the requirements, something that you need to do as engineers is read your requirement, read that sentence that for you is a requirement, and check if that sentence follows the following principles. That if you read the initials, they are known as the INVEST principles. Every single requirement, every single thing that you assume is a requirement should be INVEST. should be independent, negotiable, valuable, estimable, small, and should be able to be tested. If you tell me that something is a requirement and you review each of these items and for all of them you put a check mark, that is a requirement. But if you have a statement and when you read the statement, one of these cannot be done, cannot be tested, it's not small, it's not negotiable. If for some of these ideas you say no, that sentence could be a necessity, could be a need, could be something that the customer wants, is not a requirement. Makes sense? Requirements and necessities, requirements and user wishes are not the same. If something is a requirement, it should accomplish this validation, the invest validation. Think about this. In your exam, in your quizzes, I am going to show you some sentences and I am going to ask you, this is a requirement. When you are clicking in the yes or the no, remember these ideas. And I am going to show you examples, don't worry, but these are the ideas that you should remember. Now, independent, negotiable, valuable. We need to check examples. Let's review a project. In a project, moving forward. Imagine that I am your customer and I need a piece of software. You are my engineers. You are going to listen to my requirements and then you're going to document them. By documenting the requirements, you have the opportunity to ask me, this is really what you want, right? You can document that as user stories or as diagrams. I don't care. You know what I want? I want you to do a Pac-Man video game. Can you do a Pac-Man video game? Do you know what is a Pac-Man video game? Do you know Pac-Man? And hopefully that is a yes for everyone, right? I mean, if I mention the Pac-Man video game, I am assuming that all of you know what I am talking about. I do not need to give you more details about the necessities that I have. It's like, oh, okay, I play the Pac-Man video game sometimes. So what you are asking me to do is use my skills as a developer to create a piece of software that do exactly the same. I want a Pac-Man video game. This sentence is a requirement, yes or no. Question in your exam, that one is a requirement, yes or no. Green or red, click something, let me know. Don't worry, it's not going to impact your grade. 5 no's, 2 yes. There are 92 people, so. Okay, good. Good. Excellent. Guys, no, it's something that I want. It's not a requirement. What is the difference? This is the difference. I want a Pac-Man video game. That is small. Let me tell you what is small. Something is small if one developer can do it in one sprint, in terms of agile, in terms of developing. If you can do something, one developer, in 1 or 2 weeks, then that thing is small. One developer in 1 to 2 weeks. You think that you can create a Pac-Man video game in 1 or 2 weeks? Obviously, it's subjective. Maybe you are very, very good. But in general, the average, the answer is no. And therefore, my request is not one requirement. Can you split this in requirements? Can you start with this problem? I want a Pac-Man video game. And starting there, can you tell me the requirements for the Pac-Man video game? And what I am asking you to do is analysis. What I am asking you to do is understand the problem. The problem is doing a Pac-Man video game. And the first step in the problem is just to be sure that you understand what I want. Explain to me what are the requirements, what are the tasks involved in doing the Pac-Man video game. And in doing so, what you're going to do, what we do, is a list of the requirements for the Pac-Man video game. These have two things. Number one, when you create the requirements, it's your opportunity to double check with your customer that you understand what the customer wants. Second, those requirements are going to be the starting point for the design, and therefore the starting point for the developing, for start programming. The first thing that you need to do is to understand what you are going to do. I need your help. Which are the requirements for the Pac-Man video game? Can you tell me requirements for Pac-Man video game? There is 1, 2, 3, 10. How many requirements are involved in doing the Pac-Man video game? If you work in 360 and you learn how to do the use case diagrams, maybe what I am asking you to do is, can you think about the diagram? Even though the only thing that I care is the text inside of your ovals, I do not care yet about the connection between ovals. I am just asking you for what ovals are you going to create and what sentence are you going to put inside of them? Or if you prefer to work with Agile, what I am talking about is, can you tell me all this I want, what I want? Requirements for Pac-Man, can you give me one? What is the Pac-Man video game a requirement? Eat the dots. Okay, eat the dots, generate blocks, working outside. Okay. Those things in the chat, I like it. Yes. Now you are moving forward. Maybe you remember that we reviewed this example before. The levels. Okay. The lives. Okay. Let me start with something very, very simple. Use to create a path for this. Can you agree with me that one requirement in the Pac-Man video game is you need the Pac-Man? I mean, it is called the Pac-Man video game, so we need Pac-Man. We need the Pac-Man. Now, what we need with the Pac-Man? Requirement number one, you need, I want to draw the Pac-Man. I mean, one thing in the software is I want to be able to draw this thing. And if you want to include in the draw moving, it's fine. Can you agree with me that that is one requirement? One requirement, a trivial requirement. Tell me, drawing the Pac-Man. Be careful. I am not talking about moving. I put draw. Not move, not control, draw. Drawing a Pac-Man on the screen is something that one developer, only one, can do in a week, two. And if you tell me no, we have problems with the technical skills. If I ask you, one of you, to draw something like this on the screen in 1 week, that is your assignment, I am pretty sure that you can do it. You can create one class, maybe you can create one method, or one method inside of one class to do this. This is one requirement. Really? It is something that can be independent. It is something that can be done and is not connected with other things. I mean, can I work in drawing the Pac-Man and can I forget the maze and the ghost and the scores and the levels and all the other things that you are mentioning here? And hopefully you agree with me, like, yeah. I mean, in some point, we're going to need to put things together, but drawing the Pac-Man itself is something that can be done independently. Because, as we mentioned before, it's going to be one method in one class or something. Negotiable. Let me be clear. Negotiable. This is all about understanding that the requirement is talking about what to do, not how it's going to be done. That we all, even though we are programmers or not, even though we have or not technical skills, we can talk about this requirement and we can negotiate it because we understand the value that that requirement has. Maybe some of you are developers. You know how to do programming in Java and you're thinking about what I am going to do in Java in order to draw this yellow circle on the screen. And you're thinking about the difficulties of using the graphics or whatever. Maybe I'm not. However, technical skills or not, that draw Pac-Man, that sentence, it is clear for both of us because it's not something technical, because it's not something asking for, I need a menu, I need a panel, it's something that the customer and all the stakeholders can understand without matter of the technical skills. And because we understand, we can negotiate. Drawing the Pac-Man, I think is pretty good, something that we can negotiate. You want a Pac-Man video game? I need to draw the Pac-Man. Yeah, makes sense. It has value for the customer? I think it's pretty valuable. Can you estimate the effort? If I ask you to draw, now I am thinking about the technical. If I ask you to draw the Pac-Man on the screen, can you tell me how many hours do you need to do that? And let me be clear. I am not asking you to guess. I am asking you to tell me how many hours do you need, and I am assuming that you're thinking how many lines of code you're going to create in that time. Can you figure out how many lines of code do you need to draw the Pac-Man? Now we're talking about analysis. Let's see. Professor, you're asking me to draw a circle, yellow, with maybe this triangle here, with maybe another circle here, the eyes. Okay, you're asking me to draw something. In order to draw something, I need to use graphics. In order to use graphics, probably what I can do is using the paint component method. So basically I can do all of this in one method, paint component. Then inside of the paint component, what I need to do is to call this draw oval from graphics, and maybe 2 times, so 2 lines. And then somehow I need to draw this triangle here. Okay, there is another instruction to draw polygons, things like that, 3 lines. I need to change the color maybe 2 or 3 times, 6 lines. Okay, the class is going to be around 10 lines, 20 if you want to do something fancy. 20 lines, I can do the Pac. I can do what you are asking me, because you're asking me only to draw the Pac-Man. You are not asking me for moving or algorithms, whatever. Just for drawing the Pac-Man, 20 lines. 20 lines. And I can test it. 20 lines, I can do that in 1 hour, 2 hours, 3 hours, depending on your skills. Done? Yes, I can estimate the task because I know what I am going to be doing. Is it small? Well, very, very small, now that we are talking about 20 lines. Can be tested? Obviously can be tested. The Pac-Man is on the screen or not? Check or not? All this here. Another requirement. 2. Well, I have the Pac-Man And I am sure that you can think about, well, we can draw the ghost. Maybe we can draw the maze. Let's continue with the Pac-Man because it's the most important. Can you agree with me that a second requirement is Professor, why you do not put together draw and move? Because the goal of the requirements is to be small. You are not going to use and the connection in a sentence when you're creating requirements. You're going to create two sentences because that means two different people working. Are you telling me that you want two people, different people, one working in drawing the Pac-Man and another one working in moving the Pac-Man? So you are going to want another people working in drawing the ghost and another one working in moving the ghost? Yes. Tell me, what can we do if we have two people, two of you, one of you is going to draw the paint component and another people, a different one, is going to do the movement? Because think about it, maybe I want the Pac-Man to be moved with the keyboard, but maybe I am thinking about the Pac-Man moving along with some kind of artificial intelligence playing again another artificial intelligence. It's two computers playing Pac-Man, whatever. I do not know. But painting the Pac-Man is one thing. Moving, doesn't matter the approach, is a different thing. Can that be done? Can I separate that? And if so, can you tell me how? Let's review the details. Draw the Pac-Man. In order to draw, you need a class. That class have a paint component method. Inside of that method, one of the instructions, not the only one, but it's going to be drawing a oval. I am ignoring here the colors and other things, but that instruction. What do you think are the parameters for an instruction that draw an oval? Yeah, another option is importing the image, but the parameters are going to be at the end the same. X, Y, and the size. Similar if you do the image. For the people that is doing the draw, maybe you put here numbers, just as I put numbers for the size. Can you imagine that if my responsibilities are to draw the Pac-Man, the only thing that I need to do is to put those variables here as an attribute, create the method that is going to draw the Pac-Man in those coordinates, and provide setters method for the variables. My responsibility, provide the draw Pac-Man. My responsibility, provide a class and a method that is going to draw the oval in yellow. My responsibility, give you access to someone else, you, that is going to do the movement, to access to the class in order to change the X and Y values that are used to establish the position of the draw. Another person, worst case scenario, another class, another method. In this class, in this method here, you can do whatever you want to calculate numbers. You can create random numbers, random values for X and Y. What do you do in order to calculate the values of X and Y? Randomly, or some kind of artificial intelligence that calculate a path for the Pac-Man? I don't care. I am drawing the oval. Your numbers, do whatever you want to calculate your numbers. And when you are ready, call the method draw, send those as a parameters, and we are done. This one and this one, they are independent. One can be done without the other. Yes. I can do the requirements of moving. What I am doing is calculating the next X and Y position. I can do the requirement of drawing. What I am doing is take care of the aesthetics, the colors, and so on. And the same applies for the others. Those four are requirements. Really, they are requirements, not use needs, not use statements of features in the software. And they can be used to start the programming, as I did right now, to split the work between the team of developers. That is the goal of this. A question, these four in your exam, they are functional requirements or non-functional requirements? Okay, thank you. Good. Functional requirement. Tell me, can you give me an example of another requirement in the same context of the Pac-Man video game? Can you give me an example of a requirement for the Pac-Man video game scenario that is non-functional? Well, the color is part of the things that you are going to have here with the draw. It's kind of the specifics of the draw. In Agile is the thing that you're going to have in the back of the target. The memory. Okay, something that you need to remember with the functional and non-functional is non-functional are all about quality and constraint. Remember those two words, quality and constraint. For instance, the example that I have in the chat, using less than 1 megabyte of memory, develop the game, and the game should work in a computer with less than that amount of memory. That is about quality and constraints. It's a good example of a non-functional requirement. Another one, what if I ask you, I mentioned this in the previous lecture, your projects are going to be done in Java. So if I ask you to develop this game, I am going to ask you to develop the game using Java. Use Java to develop the game. Is a functional or non-functional requirement? Question in your exam. Good, non-functional. Hopefully now you get the idea. Good. Okay, now we have requirements for the Pac-Man, at least two, drawing and moving. We have requirements for the Ghost, at least two, drawing and moving. Are you aware that the Ghost move in a different way depending on the color? Each color represents a different category of Ghost. And therefore that increase the number of requirements because some of them move according with some kind of algorithm and another one move in a different path. Can we explain as a requirement to draw the maze? Because there is some kind of algorithmic approach to draw the mazes in the Pac-Man for each of the different levels. What about it? Something that you mentioned before as a requirement, something that I read in the chat is this requirement about it. What could be the real requirement? The word it is going to be involved, but can we be more specific about a requirement in the Pac-Man scenario that involves the word it? Collision detection. I like that. The collision detection is another scenario. Remember that we talked about this idea of analysis, one problem, split in elements. It was very easy to split or to extract from the problem the idea that we need the Pac-Man, draw the Pac-Man, and the idea that we need to move the Pac-Man. That was easy. But then, if you think about collision, I am pretty sure that you noticed that well. Collision between what? Because one scenario is the collision between two ghosts. Ignore. Okay, the collision between the Pac-Man and the ghost. With or without the power thing. Without. Two different things that should happen. At least two requirements. It. Two scenarios. With impact with the score. It what? Use the ghost or these elements that appear on the screen floating in a particular version of the game. Go from something that is your problem to the different parts and split until the things that you get here at the end are your requirements. That is what is the real meaning of analysis. That is the real meaning of understanding a problem. Question. How many requirements do you think do we have in the Pac-Man video game? Total number of requirements. Agree. Well, I give you 4, so you can start from that point. There are more than 4, right? 25, I like it. Probably 50, good. If you are around these numbers, we're getting the idea. If you have 10, believe me, you need more. If you start working with the Pac-Man and you have 10 elements, 10 requirements, 6 more than the one that I give you, that is telling you that each of your lines or more than one line need to be split. Just like mentioned before with it or detect collision, you need to go and be more specific, much more specific. Questions? Now, I want you to notice that as a first example, I am showing you something that you know. I mean, everyone, the customer and you as an engineer, know the requirements here. The real problem is that we need to learn how to put those requirements in a piece of paper because we understand the problem. We understand what we want. And still, we struggle to put that understanding as a list of requirements. Imagine what happens when we do not understand the problem. Understanding and documenting, two different things. Good questions on the chat. Here, what you are thinking about is, do you remember that your requirements in use cases are these ovals? But also you remember that when you have 2 ovals, you can connect them. Do you remember that, for instance, one of the things that you can do with ovals, with requirements, is to use inheritance? That is something that you review in 360. You can do inheritance between use cases, inheritance between requirements. And now that you are asking about moving or drawing, they are not classes yet or methods. But I am sure that what you are mentioning in the chat is, well, it looks like this move can have children's. And somehow the movement of one and the other can be connected. Moreover, you are thinking about, oh, we have these cartoons, and it doesn't matter. One cartoon is the Pac-Man and the other cartoon is the Ghost. They can be kind of connected. I can have some kind of draw functionality, and what this guy is going to be yellow, and whatever, and these guys are going to be in a different way. But can I connect those requirements? If you're doing use case diagrams, yeah, that is the idea. That is the reason because you put this kind of diagrams. If you're doing user stories, well, you do not draw the things, but still you have this text. Now, inheritance is one thing. The second thing is you have inclusion or extension. What do you think is the relationship between a requirement draw and a requirement move? If you remember 360 and inclusion and extension, what do you think? Draw and move are connected with inclusion or extension? If yes, which one? Inclusion or extension? Neither? Sure? What are you doing with the move? With the move, you define the value for the X and Y coordinates, right? Can we think about drawing and moving being connected, and basically in order to draw, the first thing that I need to do is move? Even at the beginning of the game, the first thing that I do is move the Pac-Man to the center of the screen. It should be in some place, right? Can you think about drawing be connected here? Every time that I move, well, moving do not make sense if I do not draw the Pac-Man in the next position. Every time that you move the Pac-Man or the ghost, every time that you calculate a new X and Y coordinate, something that you do is to draw next. Every movement includes a drawing. My goal here, at least for today, is not to talk about the connection. Don't worry if you do not remember these connections. I am going to do a big parenthesis introduction thing later. For now, my goal today is for you to be able to create the text that go inside of these ovals or the user stories. For you to be able to identify what is a requirement and what is not a requirement. For you to understand that if the customer, myself, I ask you to do something, that something, even though it's I want, is just a necessity. And in order to create requirements, one of the first things that you need to do is to validate the invest characteristic. When you read a sentence like draw the Pac-Man, move the Pac-Man, or whatever, the ones that you are going to do as a homework, read your sentence and ask yourselves, this is independent, can be done without a problem with others. This is something valuable for the customer, really something that should be done for functionality. Another thing that I need to mention here, when you are doing a use case, these ovals in the use case, all of them are functional requirements. Use cases are for functional requirements. All the things that are not functional are not going to be in those diagrams. So functional requirements, your diagrams. But well, when we talk about this invest, they apply for both functional and non-functional. Value, negotiation, can I estimate them, test it? And the most important, they should be small, 1 week of work, 1 people. Knowing this, homework, can I ask you to work with a team? You can work alone if you want, but I will suggest 4 people. Can you work with 3 of your friends, 4 people in total? And can you create a list of the requirements, the full list of requirements for the Pac-Man video game? And my goal is to review those with you in our next lecture. Can you do that? Well, if you do not have friends, 2 ideas, you can start doing friends now, or you can work alone. I mean, I am fine with both options. I can do 2 things, guys. Number one, I can create teams randomly. Right now, I can just create randomly discussion groups, and you're going to automatically be assigned to a team randomly if you want to do that. Or I can give you the opportunity to join with your friends. I could be okay with both options. The only thing is I need you to work in the requirements for the Pac-Man video game. The requirements, a list of requirements. I am not asking for diagrams or any particular template to follow. Use a document with a list of requirements. And I am going to ask you to submit that on Canvas. I am going to send you, open a link for that, your first assignment. Only 1 people in a team submit. So if you're in a team, just make sure that 1 person submit, put the names of all the people that participate, and you submit your document. As you mentioned, at least I am expecting something around 20 lines, 20 requirements. It is okay if you include functional and non-functional, but please, 10% can be non-functional because I really didn't mention that. What I want is for you to work in the functional requirements, in what is the functionality in the Pac-Man video game and how do you split that functionality in a group of 20, 25 or more sentences. Makes sense. So are you okay if I allow you to do your own teams? I would prefer that option. That is okay for you, everyone? Good. So what I am going to do is I am going to stop here. I am going to close my audio and my video, but I am going to leave the session open so you can use the chat. If you want to search for a team, make friends, you can talk with the people in the other social net, Discord, or if you already have friends, you can start working by email, but homework to submit before our next lecture. I am going to put the due date on Canvas. The requirements for Pac-Man, I am expecting at least 25 lines, 25 requirements, and you can reuse the 4 that I mentioned during the lecture, so that is fine. So you have to do 21 more. Good? Any last minute question? Okay, guys, see you next week. Thank you.